Good morning. Assalamu alaikum to everybody. My name is Salimul Haq. I'm the director of the International Center for Climate Change and Development, which is the secretariat for the Gobeshona platform and organizes this annual Gobeshona conference. It's my great pleasure to uh, welcome everybody who are participating and particularly thank the chairman of the Barind Authority and colleagues from Rajshahi University and other researchers who are going to be making presentations today. I will start with a little bit of background and history. The Gobeshona platform or consortium was set up 7 years ago uh, with a group of organizations and universities and researchers who are doing research on different aspects of climate change in different parts of Bangladesh. We came together and we felt that it would be a good idea to join forces or at least form a common platform where everybody can share their work with each other. And we came up with the name Gobeshona as the name for this platform, and we created it. And we have a website, gobeshona.net, where we normally collect scientific publications that are on climate change and Bangladesh. They have to be both climate change and Bangladesh. And we now have well over 2,500 publications in a archived, searchable database that reflects the level of research that is going on climate change in Bangladesh, which is very, very substantial. We add at least one new paper once a week, almost regularly, that shows the publications that are taking place. And at the same time, we also we used to hold it as a physical seminar every month. It would be hosted by one of the partner organizations, and currently we have more than 50 partner organizations, mostly universities, but also NGOs, government institutions, and quite a number of international organizations who also work in Bangladesh. And so the monthly seminar has become a webinar now. We now do them online. And then we have a big annual conference. The last 6 years, we had this as an in-person conference, always hosted by our university, the Independent University Bangladesh in Bosundhara, Dhaka. We would typically get 300-400 people over 4 days. It was a 4 days long conference, and we would have plenary sessions and parallel sessions. And we are very pleased that every year, along with the chairman of the BMDA, we had a session on the Barind. And I'm very glad that that session is now continuing in this particular conference. But this year, this is the 7th year of the old series, we are going virtual. It is a online, 100% online conference because of COVID. But what we also decided to do is to, um, by virtue of the fact that it is now an online conference, we decided to make it into a global conference. And we reached out to partners and friends around the world, and we got a huge response. Uh, Organizations from all over the world have very kindly offered to host sessions. And so what we did was we went from 4 days to 7 days. And instead of just a 9 to 5 session or meeting that we used to do in Dhaka, we have gone into 24 hours every day for 7 days. And we started the 24-hour cycle yesterday morning, and we already had about 9 sessions over 24 hours, which went very well. And this morning, this is, I think, the second in the series of sessions that are going on, and and we have 90 sessions altogether over the 7 days, 24 hours a day. We have teams and colleagues in different parts of the world. We have 3 major 8-hour segments. So this 8-hour segment is for the Asia Pacific region. Then we will hand over for another 8-hour segment for the Africa and European time zones. And then we'll hand over for another 8-hour segment for the Americas, North America, South America, and Central America. In fact, some of the South American sessions are also in Spanish because they're predominantly Spanish speakers there. And as I said, we've just done the first 24 hours, and that worked out quite well. So going forward, we have decided, and the other important note on the new theme, the global theme is locally led adaptation. So that is our forte, that is our area of interest and specialization. Last year's conference, we had Mr. Ban Ki-moon, who is the chair of the Global Commission on Adaptation. He gave a speech uh, launching the Global Commission adaptation work on locally led adaptation. And we have been very much involved in this. It's a global effort. It's a big global group of partners who are working on this. And we have decided to make our annual conference on locally led adaptation. And yesterday at the opening session, we had Mr. Ban Ki-moon again give us a speech uh, uh, um, giving us encouragement to continue this. So from now on, given that this is the first year of a new decade, 2021, we plan for the rest of this decade to 2030, which is the culmination of very important sets of activities, the Sustainable Development Goals, 17 of them, and the Paris Agreement on climate change, two goals, mitigation and adaptation. So over the next 10 years, every year in January, we will hold the Gobeshona conference as a online, virtual, global conference on the theme of locally led adaptation. That is our intention going forward. Now, given that there is a history of it being primarily a Bangladesh based conference, it's no longer primarily Bangladesh, but it's now a hybrid. It is both global and Bangladesh. And the session on Barind, which we have been doing for the last many years, we hope we can continue that. I'm very glad that you have kindly offered to run that session. This is a primarily Bangladesh based session, but it is about drylands more generally. And there are people all around the world who have similar problems who will want to know about what is happening in Bangladesh. And one of the objectives of the Gobeshona conference is to share the experience of Bangladesh with the rest of the world. And I hope that we will get a lot of people to participate and listen in live. But even more important than the live participants is, and we have found this from our own experience, is the recording. We will record the entire event and we will produce a report on the session, and we will disseminate the recording and the report very widely. And our experience has been that a lot of people who were not able to join the session, for example, right now, people living in Europe or in America are sleeping. This is not a convenient time for them. They won't be able to join us live, but they will be interested in seeing what happens here, and they will watch the recording in their own time later. And we have seen that the live audience number can be easily doubled over time. It takes a little while by the number of people who will watch the recording afterwards. So please bear that in mind. You are not just speaking to a live audience, but you are speaking for the record, and your thoughts and your ideas and your comments and your information. This will be a permanent record, the recording, and people will be able to see it in future, and you can share it with other people as well once the recording is done. So the dissemination of this is, again, our, normally in the past we would have a written proceedings, a book, we would publish everything after a month or two after the conference, and we had a hard copy of the conference proceedings. We are not doing that anymore. The days of the hard copies are over. Printing is now old technology. We have all gone online. So what we are going to be doing is we are going to do this all online, and we are not going to wait for all the sessions and write one big proceedings for everything. Every session is a session in its own right. It will be disseminated and publicized to a wide audience. People have different interests. Some people are interested in one session, some people are interested in another session. Uh, so you will gather people who are interested in your session by publicizing, and we will have a record of the event, and we will have a report on the event. The rapporteurs will prepare a written report on the event. So each session will have its own output, a recording and a report that will remain a permanent record on the website, and we will be able to publicize and share that with many people. And as I said, the recordings do get quite a large audience. So please keep that in mind. This is not just talking to a live audience of however many we may have, but it is also about recording this for posterity and for people in the future uh, to be able to watch it. So, and the last thing I will suggest for your consideration is in the last few minutes of your session to give a little bit of thinking about what to do next. This is something we are asking all the sessions to not just see this as a show and tell and present and then go home. You should think about what do we need to do next. Come up with some kind of a what is needed, what needs to be done, how can we do it. And what needs to be done is not recommending government should do something. That's not a plan. The plan is what are you going to do, what are we going to do. It's come up with a plan that we can do, that we can implement. And in particular, I just mentioned this before we opened. One of the issues were that the time constraint does not allow you to have as many presentations as you had wanted to do. And maybe next year we can give you a bigger time allocation. But please plan next year now. Don't come to me at the last minute and say we want a lot of time, but we haven't planned anything. Please prepare the plan now, and then definitely we will consider it and we'll find a way to accommodate it for next year, January 2022. That is the timeline I'm offering you to start your thinking and start your planning. So please think ahead, think about what needs to be done next. And in that context, what it is that we as researchers, as administrators, as potentially donors and funders involved here, international agencies, what is the role that we can collectively play to take forward the issues that are very important issues in the Barind in Bangladesh. This is one of the most climate vulnerable regions of the country, is a similar vulnerability to many other drylands around the world. How can we link up with the other drylands around the world and do some work together on this? So it's a great pleasure for me to welcome everybody and thank you for taking the initiative to do this session and hand over to the chair of the session, Dr. Akram Chowdhury. Dr. Akram, please carry on.
Bismillahirrahmanirrahim. Rabbi Shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. It's my privilege to welcome you, including Professor Salimul Haq, to 7th Gobeshona International Conference 21. And the conference focusing on theme locally led adaptation action. And our theme is dryland and buried. And the session title is Adaptation for Water-Stressed Barren Dryland, Northwest of Bangladesh. This is a proud privilege that I'm going to welcome you to this session. And let me, at the beginning, I, I must not say about the physiographic situation in barren land, because there is lots of paper. But what I wanted to do is to introduce the concept note paper, concept note presenter, Professor Chowdhury Sarwar Jahan, Department of Geology and Mining, University of Rajshahi, former Vice Chancellor, University of Rajshahi, Bangladesh. And also we have one speaker from Holland joining us, Mr. Bashir Mohammed, who was former head of Asia and Middle East 2030 WRG, Water Resources Group, International Finance Corporation, World Bank Group. And also we have a distinguished moderator, Dr. Alan David Mackhawk. And as you know, Professor Salimul Haq, who has also kindly joined with us. Salimul Haq is the director of the International Center for Climate Change and Development and professor at the Independent University of Bangladesh. He is chair of the Expert Advisory Group for the Climate Vulnerable Forum and also senior advisor on locally led adaptation with Global Center on Adaptation headquartered in Netherlands. He's an expert in adaptation to climate change in the most vulnerable developing countries and has a lead author of the third, fourth, fifth assessment report of the Intergovernmental Panel on Climate Change, IPCC. And he also advised the least developed countries, LDC, group in the United Nations Framework Convention on Climate Change, UNFCCC, the top 20 global influencer on the climate change policy in 2019, and top scientists from the Bangladesh on climate change science. I welcome you. And I must express my heartfelt thanks and gratitude to Professor Salim Haq because of the opportunity he has given to Barind subgroup. Uh, uh, it is our pleasure to work with him for a long time, and it's really we feel that he's our mentor in this field, and also we want to share everything with the is an opportunity to share all those things to different you know uh, different parts of the of the world globally. Now I also introduce uh, uh, our moderator, Dr. Ellen David Mackop. He's a consultant of Regenerative Asia, and his extensive international programmatic sustainable production ecosystem utilizing regenerative agriculture, which was the basis of his PhD. Now we have Professor uh, Sarwar, Chowdhury Sarwar Jahan. You know, he's very well known expert in this country with regard to water. So, and we have a number of scientists joining us, and we have divided our session and clustered the paper uh, into soil management approach, then then drought and water resource management approach, agriculture adaptation approach, social adaptation approach, and we have then opened the forum and it's opening session, and then Bas Mahaman will participate as a commentator, as a panelist, and then followed by concluding remarks by Dr. McHawk. This is the session is all about. I'm going to hand over now Dr. Um, Dr. Alan David McHawk to, this is your floor now. Thank you again for participating into our program. And we hope that your insightful thoughts will help us to develop more program, more action plan in Barind tracks. Thank you very much.
Thank you, Dr. Chowdhury, for those remarks, and
Alex.
thank you for Salim Al-Haq as well. Just to move straight on, I would like to give the floor to Professor Chowdhury Sarwar Jahan to deliver his concept note. Sir, you have 5 minutes. Thank you very much.
Honorable Chair, Honorable Moderator, dear participant, Assalamu alaikum and very good morning to all of you. I am really grateful to speak few words on the adaptation of water stress dryland session of the 7th Gobeshona International Conference 2021. Bangladesh, a country of rivers, but most vulnerable to disaster with the negative consequences associated with various natural and human-induced hazards. The National Water Policy in Bangladesh in 1999 has declared the drought as a major challenge to face the water scarcity issues in its agro-based northwestern part, especially in the dryland Barind. The major part of the northwestern part comprises of elevated and dissected landmass of the Pleistocene age, and rest of the floodplains of the major rivers like the Tista, Korotwa, Mahananda, Purnabhaba, Atrai, and Podda. Almost 80% of the rainfall occurs during the monsoon season, June to September, obviously, and that remaining 20% in the rest of the months. Total number of dry episodes have higher occurrence in the recent decades and number of drought events with the middle to moderate nature. Agriculture, meteorological, hydrological droughts have increasing drastically in the winter and pre-monsoon season with steady increasing trend in the rainy season. Moreover, we are not as certain of getting the same amount of rainwater every year. Frequency and risk ranking of the drought effect is highest with the moderate to high condition. Future climate change projection of Bangladesh and Barind Island show increasing rainfall during the monsoon season and declining rainfall in the winter months. The rainfall variability may increase significantly, causing the more intensity with long dry spell and must be addressed by adaptation. The economic activities of the Barind community are climate sensitive. Apart from the loss of agriculture, drought have significantly effect on the land degradation, life, livestock population, employment, and health. Drought also leads to increase in severe chronic energy deficiency among the members of the agriculture workforce. If climate change occurs faster than those affected can adapt, community vulnerability to impact of both the climate variability and change will increase. It has been predicted that 2025, the demand for irrigation may reach 60% of the total supply. The Bangladesh agriculture sector contributes about 15% to its GDP. Nearly 30% of the population is directly or indirectly depend on the agriculture. Though declining, but agriculture is still the high contributor to GDP and main user of water. The share of water demand will continue to increase and concurrent with efforts to attain the food security. Experts and researchers say that the drought may normally affect the 2.3 million hectare of cropland from April to September and 1.2 million hectare in the dry season, that is October to March. Drought during the monsoon season severely affect the tea almond rice and can incur an annual 1.5 million tons of production loss. Incidence of pest and disease has increased with the increasing drought frequency. The physical and social disruption have caused by this disease and extreme events that may affect the community. Local communities trying to cope with climate variability based on their experience in managing the climate extremes. Livelihood adaptation to climate change is a continuous process, but on the social economic circumstance and adaptive capacity of the community. The basic understanding in the context of drought adaptation is the adaptive option should have the potential to improve the livelihood asset of the rural hard to reach dryland Barind. Moreover, improved climate information and prediction is one of the most important elements for adaptation. Generally, forecasts involving weather and climate are divided into short range, medium range, and long range types based on their lead time. The present good adaptation practice due to drought in dryland Barind includes the homestead garden, orchard cultivation, rainwater harvesting for integrated water resource management plan. At the end, the impact of increasing drought are global concern. In dryland Barind, number of peoples are chronically exposed and vulnerable to drought effect. Now it is a time to design for characterizing livelihood system, profiling vulnerable groups, assessing past and current drought impacts, increasing understanding of the local perception of the drought impacts and coping capacities, and understanding the knowledge of existing adaptation strategy urgently. In this regard, capacity building for adaptation to drought should be taken for disaster managers and community. More initiative should be taken to identify for the sectors and location specific adaptation practice and building awareness in rural livelihood to drought effect in agriculture as well as judicious water management practice. Thank you for patient sharing. Thank you all.
Thank you so much, Professor Chowdhury. Very good, very welcome introduction to the issues surrounding the Barren Tract area in northwest Bangladesh. Thank you very much. Ladies and gentlemen, we'll now move on to our individual presentations. Our first session talks about soil management. We have 3 papers in this regard. Each of the speakers have about 5 minutes to deliver their main findings and the main concerns. First off, we have Dr. Mizan Rahman from the University of Rajshahi. His paper is on the assessment of heavy metal soil pollution in agricultural land of northwestern Bangladesh. Mizan, please go ahead.
Just a minute,
No,
please. Yes. Let me share my screen first. Can you share see my presentation?
Sure, sure.
Yes, looks
Okay.
Dr. Mizan,
go ahead.
Okay. Dear session chair, honorable moderator, and key concept presenter, and distinguished researcher and participants, I would like to welcome everybody to my presentation. In favor of my research group, I will talk about assessment of the heavy metal soil pollution in the agricultural land of northwestern Bangladesh. We know Bangladesh is an agrarian country. Still now, more than 70% people directly or indirectly depend on agriculture and its allied activities. Due to allocation of small amount of per capita land, food deficit was regular phenomenon few years back. But then government has been taken policies and programs to modernize the agricultural system since the 6 decades of the last century. It brings success to produce surplus food in lieu of application of modern agricultural inputs, especially chemical fertilizers, pesticides, and use of underground water and so on. But these agricultural inputs have brought adverse impact on soil, especially through accumulation of heavy metal in soil. So it is necessary to do research on the issue and find out the way to overcome the situation. In this regard, these are the aims and objectives. Firstly, we investigate the heavy metals accumulation in the agricultural soil of the study area. Then we analyze the pollution level by applying different pollution measuring techniques. Then we discuss the spatial variation of heavy metals pollution based on individual and as a whole pollution level of the study area. Our methodology is here. Firstly, we identified the problem, then we select the study area. We have taken 10 villages from Hujuripara Union, which is included in the Poba Upazila of Rajshahi district. You know, Rajshahi district is the northwestern district situated in the northwestern part of Bangladesh, you can see here. Then we assess the data needs, what are the data we need for this study. Then we generate data. We collected last minute. We collected samples and sent to the SRDI lab. Then we applied different type of techniques to analysis like SPI, NCPI, and spatial pattern analysis. Then we apply the statistical procedure to find out the relationship among the heavy metals, then find out the class principal component analysis to find out the source of the heavy metals. Then we find out the test the cluster test. Then we present the final result. Major findings of the result here.
Last minute.
Yes, here we can see the all the villages are almost polluted by the heavy metals. We have taken 7 heavy metals: chromium, lead, ferrous, cadmium, zinc, nickel, and copper. Among these, chromium has the most hazardous effect of soils, and 100% soil is polluted by these heavy metals. followed by the cadmium, lead, and ferrous. 90% soil is severely polluted, and we found here Shorishakuri village is highly severely polluted, and mildly polluted is Huzuripara. So PCA analysis suggested that chromium, lead, copper, zinc, and nickel, which are predominantly derived from the agricultural sources, while ferrous and cadmium probably are from mixed sources, both agriculture and geological. So since agricultural inputs and their application are the main contributor to ASM's accumulation in the agricultural soil, government should realize the severity of the problems and reformulate policies and programs to develop pollution control practices and effective soil remediation and management. Thanks for your kind attention.
Thank you, Mizan. Thank you very much. Just moving on quickly, that was very informative. Moving on quickly, our next speaker is Dr. Nurul Islam from the Soils Resource Development Institute. His talk this morning is on the effect of organic matter at liming on soil properties, growth rates and yield of wheat grown in acidic soil of the high barren tract area of Bangladesh. Thank you, Nurul. Please go ahead.
No, just open this slide of Dr. Nurul Islam. Noor. Sohail, do you hear me?
Sohail, please.
Sohail, Noor or Noor?
Sir, please hear me.
Sure, you can start your lecture.
Okay, so welcome to the presentation, 7th Gobeshona International Conference 21. Thanks to the organizer, especially thanks to BMDA Chairman, Dr. Akram Chowdhury and others. So just I started, the time is very late. Soil acidification of Bangladesh. We know the acidification Barind area is very problem. The important issue is the very much important issue in our side. Adverse effect on soil fertility and crop productivity. Acidic soil are widespread in northern district of Bangladesh, particularly in the Barind area. Soil acidity has become a major problem for crop production. Out of 8.5 million hectare acidic soil in Bangladesh, 4.6 million hectare is moderate to extremely acidic acid, pH value less than or equal 5.2. And acidic soil may constant crop production in more than 30% of land in Bangladesh.
Can you switch to presentation mode, please?
No, just switch.
So start. So hear me, everyone.
Sure. You just continue.
Beneficial of liming. So the liming is the very important for problem the acidification. Eliminates the toxic effect of aluminum, iron, and manganese. Increase the availability of phosphorus, molybdenum, calcium, magnesium. Improve soil physical and chemical properties, crop yield improvement, improve microbial activity, and improve legume fixation.
Next.
The added organic matter. Organic matter is very important for soil quality development, especially degraded soil. Our Barind area is the degraded soil, so it is very important, especially light texture soil, heavy acidic soil, and the nutrient status is where is very low. This organic matter is very important. This picture, this slide show this. My experiment title was Effects of Organic Matter and Lime on Soil Properties, Growth Rates, and Yield of Wheat Grown in Acidic Soil in High Barind, Tag Bangladesh. This is the objectives to evaluate the effect of lime on yield and yield contributing characters, to determine the rate of lime at different pH level, to determine the change of soil chemical properties, to find out the trend of soil health, and improvement of environment after subsequent liming to assess the microbial population in soil. There was the next, the description, the design. Experiment design was RCBD, repletion 3, treatment 5, and I was used as organic matter, 4 kg vermicompost. You already saw this picture, liming and organic matter applied, and balanced fertilizer applied in the field. I got the results. The effect of liming on soil fertility of post-harvest soil of wheat field. These are the tables. Saw these the results, the chemical properties, soil properties, the initial soil values, the red marking this, and after liming application and organic matter, there are so many change the soil properties. And I was used 5 treatments, among them 1.0 ton per hectare and 4 kg vermicompost, that is organic matter. That was the best result. The changing the soil properties. And the next, on the yield effect of lime, also effect on liming application, wheat yield and others component, plant height, tillers, spike length, grains per spike, and 1000 grains weight, and grain yield also affect the liming and organic matter. They are also 1.0 ton per hectare and organic matter 4 kg per decimal. That was the best result showing this. And after this, our observation and conclusion, this experiment, the application different rates of lime, increase soil pH 0.2 to 1.6 unit, and increase availability also calcium, magnesium. We know the phosphorus is the main problem in Barind area. If we apply the lime, phosphorus availability also increased. And treatment 1.0 and organic matter also is the important. And liming effect, pH also increased. And the important, very important issue, the microbial population also increased after organic matter and liming application. You see the red marking, 1.7 into 10 to the 6. This is initial, and after liming and organic matter applied 2.9. That is the organic matter microbial population in soil microbes is also increased after liming and organic matter application. This is the very important for my experiment. And in the Barind area, you know, the Barind area is low organic matter. And this is the pictures. Some pictures my field experiment. You saw the last next slide. The liming application, organic matter, vermicompost apply. Next slide, please.
No, next
Thank
slide.
you, Nurul. You'll have to finish up, please.
Just to finish.
Just a second. This is the picture on my experiment. Microbial effect. This is the wheat grown field, and at first the liming application and vermicompost application, measurement of valence chemical fertilizer and apply, and then microbial population, the roles of microbial population. This is the slide. Agriculture, production, food industry, and medical industry. It is very important. And this two slide, my next two slide, the culture, microbial culture. Just see. Thanks to all to hear me my presentation within short time. Thanks everybody.
It's our pleasure. Thank you very much, Nurul. It's very interesting to hear about the improvement of wheat production and the soil microbial density increases. Thank you. Our next speaker is from the Bangladesh Biochar Initiative, Mahbub Islam. His talk will be on the climate change adaptation potential of household produced biochar in northwest Bangladesh.
Yes.
Mahbub, are you there? Yes, please go ahead.
Yeah, I'm here. On behalf of Bangladesh Biochar Initiative, Dr. Saifullah will present. Dr. Saifullah. Dr. Saifullah, do you hear me? Dr. Saifullah?
I think he's not here in the session.
Yeah,
maybe.
no, he's in the session.
Yes, I'm
I
here.
saw him.
Oh, just
Can you hear me,
Okay,
gentlemen?
you continue.
Thank you, Dr.
Yes,
Saiful.
you go ahead, Dr. Saifullah. Okay.
Okay. Thank you very much. Thank you, Dr. Ellen McHow. So what we are going to present is not a complete paper. It's a paper in the making. And thanks to Professor Chowdhury and Dr. Nazrul Islam, they made our presentation easy because they just describe the background of what we will be talking about. So the theme of the conference is like a locally level adaptation. So what we are thinking about the Bangladesh Biochar Initiative, if I give a 1 minute background of Biochar Initiative, things will be easier for the audience. So Bangladesh Biochar Initiative is dedicated to promote the production and use of biochar in Bangladesh. So in short, biochar is like world known as a soil amender, but as Dr. Nozul Islam said, the different characteristics of soil in the Barind areas, we considered from our experience and research done internationally that biochar can be a solution for all these problems mentioned earlier. So that's why, when we talk about drought, we talk about dry lands, we talk about dry agricultural lands, the research, Dr. Allen has a vast experience on this as well. So with us, Dr. Julian, he is an international expert on biochar promotion and soil improvement. So what we thought about that, in age of climate change, who is seriously affecting the lands in northwestern part of Bangladesh, biochar could be one solution for that. Why? When we talk about drought is basically a meteorological drought. We cannot control the rain, the sun, and so on. But what we can do, we can mitigate the eventual effect of this drought. That's why we thought about biochar and use of biochar in that part of Bangladesh. And okay, when we talk about biochar, the first question comes, how do we get biochar? To answer that question, Bangladesh Biochar Initiative came into being. That we have devised a pyrolyzed based device to produce biochar at household level. Why at household level? Because in Bangladesh, we don't have that luxury to produce biochar industrially because we don't have that much biomasses in Bangladesh. And basically, we are short of biomasses in Bangladesh in terms of forest resources. So, internationally, what they call about biochar through household waste or agricultural waste, we turned it to in Bangladesh that the common cooking practice in Bangladesh, we use that common cooking practice into Bangladesh into a cooking device so that the households in Bangladesh can cook their food and produce biochar as a residue. So in Bangladesh, nowadays, biochar is not an issue because BBI has already installed almost 500 this device to different parts of Bangladesh. And almost all the universities in Bangladesh have been using our biochar for researches, and a lot of farmers are using biochars in their croplands. So that's why we thought that biochar could be a solution to the problem of
Dr. Saiful, your last minute, please.
Okay. So what is our proposal? Our proposal is that we are going to conduct a big research on the effect of biochar on dry lands like land in the northwest part of Bangladesh. And hopefully, if we can conduct a good research, we can come up with a good solution, hopefully in the next Gobeshona conference, so that we can have evidence-based data that yes, biochar can at least mitigate the issue of dry lands in northern part of Bangladesh and there are supports from there, like Professor Akram Chowdhury, Professor Salimul Haq. Hopefully, they will support us to make it disseminate widely in the next Gobeshona conference. Hopefully, and we'll get support from our external supporters as well. Thank you for all the support extended. Thank you very much for giving us time.
Thank you so much, Dr. Saiful and Mahbub, for that interesting talk about the Aka stove and, of course, producing the biochar locally. Thank you so much. We're going to move on to our next sector, which talks about water resource management as it relates to adaptation activities. Our first speaker in this sector is Tawheedul Hassan from the University of Rajshahi. His presentation will be a study on groundwater potentiality and adaptation for augmenting depleting resources in the Barind Tract, Bangladesh, using MCDM approach in the GIS environment. Thank you, Tawheedul. Please go ahead.
Thank you, Dr. Allen. Good morning, everyone. Thank you very much for having me. Can I have the slide, please?
Tawheed, just continue.
Okay, this is the title of my work, as you can see here in the first phase. Study on groundwater potentiality and adaptation for augmenting depleting resource in Barind Tract, Bangladesh, using MCDM approach. Can I have the next slide, please? These are the aims and objective. First, preparing a groundwater potentiality map using MCDM approach, then calculating the watershed morphometric parameters for rainwater harvesting or runoff water management, then delineation of groundwater research zones and artificial research sites, and then I calculated, I show some artificial research structures sites. Can I have the next slide? While this is the groundwater potentiality map of the study area, as you can see, it is very dominant. It is dominated by very poor to poor groundwater potentiality, because most of the areas has flat to gentle slope with low surface soil infiltration capacity of runoff water to groundwater research. Only 2% of the area has high groundwater potentiality and 4% being moderate, along with 77% poor and 17% very poor groundwater potentiality. So overall, this area has very low groundwater potentiality, very poor groundwater potentiality. Okay, next slide. Well, here about 65% of the area is moderately suitable and 1% is highly suitable, and the rest of the 34% is unsuitable for groundwater research structures like check dam, and these rest 34% unsuitable areas for check dam is very much suitable for artificial groundwater research structures like managed aquifer model and so on. And here the yellow pointed marks represents the suggested check dam sites for the area. That's it. And so these sites are delineated from crossing second and third order streams with lineament. Okay. And and the zone represented by red color is the possible sites for managed aquifer research techniques, which is the only option in the only suitable option in the study area. Thank you. I guess that's it. Yes. Thank you very much. Thank you, everyone.
Thank you, Tawheedul, for a very comprehensive but brief presentation. I'm sure there's more we can ask questions about to delve into your methodology. Thank you so much. Our next speaker in this water resource management section is Hossain, also from the University of Rajshahi. His talk is on turning barren land into productive one.
Mr. Sohail, I'd like to request you, can I share myself?
Sure, you
Hello.
can share.
I'm sharing your slide.
Oh, yes, thank you.
Okay. As I was saying, his talk is on the adaptive approaches to water resources management in the Barind Tract. Thank you, Iqbal. Please go ahead.
Sir, please share. Hello.
Well, share the slide.
Okay. But I am not allowed. So Soil is requested to.
Or Noor can.
Noor, would you please stop your screen sharing? Then our Soil Bhai will be able to share his screen.
Soil, please. I am not.
No,
allowed.
do you hear?
Post disabled participant screen sharing. So please share my slide.
So you can share the slide.
Sohail. Hello, Mr. Sohail. Please share my slide.
But I think there's some problem. That's why
Sir, I have back out the screen share. Please, you can now share the screen.
Now it is okay.
For your kind information, screen share is available for our honorable panelists. Also. Any panelist want to share this, then you may go on.
Hello, there is something problem, I think. So,
but you can continue your lecture. It will be better.
My contribution, sir. Yeah. Please. Gobeshona, go.
Now it is fine.
So, good morning and welcome to my presentation, everyone. Now, the aim and objective of the study. Hello?
We are listening you.
Okay, thank you, sir.
Please go ahead.
Underdeveloped and underprivileged area, people had to face serious setback, especially in drinking and irrigation before 1986. BMDA, that is Multipurpose Development Authority, came forward to overcome such situation with different adaptive techniques in water resource management. So the aim and objective of the study is to highlight the attempts taken by BMDA and in water resources augmentation and management and find the impacts. Methodology, different data like deep tube well for groundwater extraction, re-excavated ponds, canal, cross dams for surface water augmentation, dug well, and recharge well for rainwater harvesting and groundwater recharge, buried pipeline, drinking water supply installation, and prepaid metering system have been collected from BMDA, field investigation, other sources, and analyze them. All the adaptive resources, measures have been taken by BMDA, can be overviewed like this flow diagram. And I'm going to the details in the next slide. This slide, we can see the solar irrigation using surface water. A series of solar panels have been constructed over the re-excavated canals, and there are lots of solar driven pump beside these canals, and there is a cross dam across the re-excavated canal used for conserve the rainwater, and the water is coming from the Padda river through buried pipeline by the pumping and discharging to the re-excavated canal. There is also a cross dam here, and this is a re-excavated ponds, conserve rainwater, and there is a rubber dam constructed at the river, across the river. It is also used to conserve rainwater, and all these slides, the surface water is augmented and used for irrigation purposes by low lift pump or solar driven pump through buried pipeline systems. And now the deep to well scheme, there is a deep to well, groundwater is withdrawn by the deep to well for irrigation, and there is a buried pipeline. You know that Barind area is undulated terrace type land, so buried pipe is most suitable for this types of land for water distribution system. By this system, it is possible to convey water from lower elevation to higher elevation, and there is outlet of this system from where water is going out to the irrigated field. And now there is a drinking water installation. We know we have 15% of our installed deep well located near the village, so we construct a 25,000 liter capacity overhead water tank, and water is supplied to the village people through pipe network system. And we can see that a group of women are collecting drinking water. They also use this water for domestic purposes. There is a dug well, the area where there is no scope of surface water as well as groundwater. In this area, we construct the dug well, and this water is used for low water consuming crops like cabbage, wheat, and other vegetables. And we have also rainwater harvesting and research systems. Every irrigation equipment we have prepaid metering system. Okay, thank you. Now the major findings. Overall findings is the desert-like barren land has turned into productive one. Rainfall-dependent single-crop land has been transformed into multi-crop land. Installation of 15,882 deep wells along with 13,292 kilometer buried pipeline has brought 5,22,000 hectares of land under control irrigation. Due to the excavation of 3,098 ponds, 2,001 kilometer canal, construction of 747 cross dams, and the re-excavated canals, 11 numbers of floating pontoons with required pumps on the rivers, a rubber dam across the river, and using 625 low-lift pumps, 97,000 hectares of land have been brought under supplementary irrigation in a controlled way. Buried pipeline has increased the conventional efficiency, ranging 94.4.6 to 95.37, and saving 920 hectares of land for the scheme 15,882 deep well scheme. About 9 lakh people are enjoying potable drinking water in the rural level from 1,579 drinking water installation. Utilization of prepaid meter has reduced the overuse of irrigation water and thus increased command area by 22%. By one installed recharge well at BMDA office campus, 3 lakh liters of rooftop rainwater recharges groundwater in a year and 28 liters per minute by another recharge well installed in the canal. So thank you everyone to watch my presentation with patience.
Okay, thank you, Iqbal, very much. Our next speaker from Barind Multipurpose Development Authorities, Jahan Alam Khan, is talking about the design and construction of artificial groundwater recharge wells by harvesting rainwater. Thank you, Jahan. Please go ahead.
Bismillahirrahmanirrahim. Honorable Chair, Honorable Moderator, and the Honorable Participant, I like to take part in the discussion. My topic is design and construction of an artificial groundwater recharge well by harvesting rainwater. I am Mohammad Jahan Alam Khan, Superintending Engineer, Barind Multipurpose Development Authority. You know, water is very precious material gifted by God, and it is the scenario, future scenario is water will be available for 1% out of 3, and there will be a fight for water between man to man, city to city, state to state. So there is no alternative except artificial recharge of groundwater to save the groundwater depletion. What is artificial groundwater recharge? Artificial recharge, Sohel.
Nur bhai, next slide, please.
Next slide. Artificial nature is a process by which excess surface water is directed into the ground either by spreading on the surface, by using recharge wells, or by altering natural conditions to increase infiltration, replenish, and aquifer at a rate much higher than those of natural condition of percolation. Why artificial recharge is needed? In most low rainfall areas of the country, the availability of utilizable surface water is so low, and so people have to depend largely on groundwater for agriculture and domestic use. In order to improve the groundwater cessation, it is necessary to artificially recharge the depleted groundwater aquifers. Next, objective of the studies. Next. Objective of the study: to design and construct a recharge well, to increase the storage water in aquifer by harvesting rainwater through recharge well. Methodology: for the study, a research pit was designed and constructed. There are two pits. One is called settlement pit and another is recharge well. The settlement pit is used for settlement of debris, if any, in the water. And secondly, the recharge well, after cleaning the water from the settlement tank, the clean water enter into the settlement tank. Next. The dimension of the recharge well is 2 meter by 2 meter by 1.65 meter. It is dug up to 1.65 meter, which is filled by different type of stones like boulder stones, gravel, and coarse sand that will act as cleaner. Around 0.75 meter is freeboard. Below the length of 1.65 meter, there are two numbers of recharge shaft, which will convey the clean water to the groundwater level. Next slide. This is the design. You see there are two pits. This is the settlement tank and this is the recharge tank. First, the water enter in this.
Last minute, Jahan.
This is in this tank and then settle the debris. Then clean water enter into the recharge oil. There are three layers. One is coarse sand, then gravel, and then boulder. And then there are three or two numbers of shafts that will act as conveyor of the clean water to the static water level. It is around 20 meter length, and it depends on the static water level as well as the groundwater table. There are next. This is a calculation. This is a slide before, please, one slide. This is the calculation of the research pit. We have to re-excavate the earth from the pit, and then we have to set up this type of calculations, and we need on an around 1 lakh taka per establishment. Next.
Can you finish up, please, Jahan?
So this is last result, and we have a calculation. We have an command area, like the area of our office campus is 200 square meter. The annual rainfall of that area is 100 and 500 millimeter, and we think 70% is entered into the ground. So after the session, we have to 21 lakh liters of water enter into the ground. That will save our groundwater level. Thank you. Thank you for patient hearing. Thank you all.
Thank you, Jahan. Our next speaker is from the University of Rajshahi, also Jahan Alam Khan. He's talking about integrated water resource management, an adaptation tool for alleviating water scarcity in hard-to-reach barren tract, northwest Bangladesh. Thank you, Jahan.
I'd like to welcome you all. I'm sorry, Elaine, I'm not Jahan, I'm Jahangir Alam Khan from DASCO Foundation.
I'm sorry.
Sorry for the printing mistake or minor mistake.
It's okay, we got you now.
Yeah, thank you very much for inviting me for the presentation, and please, Sohail, this is our tools. DASCO Foundation is working in the high Barind tract of the northwest region. Next slide. Our objective of the study is to institutionalize integrated water resource management process in compliance with Bangladesh Water Rules 2018 in the Barind area that the Water Resource Ministry and Water Resource Planning Organization is working jointly with DASCO. The government component is working as the national component, and DASCO Foundation and Swiss Red Cross is working here in 3 districts of 39 union and 3 Purushabha to implement the water rules in the Barind area for identifying water stress area or sustainable, effective, inclusive management for use of water resources. Next. The methodology is the National Water Act is available in our hand in 2013. Then the Act turned into water rules in 2018. That water rules is the study will orient the policy to the people, and as well as it will test and pilot in the IWRM in the said areas. The piloted issues will be adopted by GOB, then decentralized IWRM committees. Institution will work, decentralized institution will work in the grassroots level. Then the subnational components, Swiss Red Cross and DASCO will provide support to function of IWRM committees, and then it will turn as institutionalization of the IWRM committees. Next. The findings of our findings and way forward of the study is actions are aimed at institutionalizing IWRM process by encouraging local government institution to integrate the 4R. 4R means reduce, reuse, recycle, and restore aligned water schemes into the annual planning and budgeting process of the citizen and local government, those who are participating in IWRM process to achieve the goal and objective, like they will develop water resources management plan in the community level, ensure community participation in local government annual budget process, community sensitization on the said 4R principle and related issues, LGA local government sensitization on the Bangladesh Water Rules 2018 and the IWRM guidelines to for integrated water resource management in the Barind area, as well as functional decentralization of the IWRM committees. The committee will function from at the root level, from where they will generate the laws and principles and policies for the benefit of the community community based on the guidelines of Water Resource Planning Organization formulated Bangladesh Water Rules 2018 and the IWRM guidelines in the district, upazila and union level, as well as formation and activated of union and union, upazila and district committees. District and upazila IWRM committees is not just we're waiting to form and activate. Local government institutions compile community water resource management plan, and that plan will be incorporated with the the community plan will be incorporated in the national development plan. We have some challenges, still a number of challenges to overcome to get full benefit of IWRM issues. It is high time to upscale the adaptation practice to rest of Bangladesh for management of water resources. Next. And thank you very much for our end. If you have any questions or queries, please carry on. Thank you.
Thank you, Jahangir. Sorry about your affiliation error there.
Thank you. Thank you.
Thank you so much.
Thank you.
Our next speaker is from Zhejiang University in Jiangxi, China, Dr. Saji Rahman. His talk is on multidisciplinary approach to analyze the aridity of the Barind Tract. Thank you, Saji. He's there somewhere. Dr. Saji Rahman.
Dr. Sajid, are you there?
Saw his name.
Hello.
Yeah, Dr.
Do you listen me?
I can hear you, I think.
Hello here.
Yeah, we are hearing you.
Yeah, please go ahead.
Go ahead. Yeah, it's okay. Honorable Chair, Session Chair, and as well as Chair of BMDA, and the Honorable Great Initiator of Global upholding such a WebNil as a global standard, Dr. Salimul Haq sir, Honorable Moderator, and Honorable Keynote Speaker, Professor Sarwar Chowdhury, distinguished researcher and guest. Assalamu alaikum. Me, Dr. Sajid and Mohiuddin Alamgir from Zhejiang University going to present on multidisciplinary approach to analyze the aridity of Barind Tract. Our main objective was to understand the geomechanical processes that made the Barind dry, and to assess the applicability of combined remote sensing, GIS, and geophysical data for explore and monitoring the hydro-environmental condition, to understand the dynamic behavior of land cover and land cover changes in relation to physiography, driving forces of land cover and land use changes. Now it's a global concern to know and monitor the local problems. Our study obviously meet the issues. Next, please. Next slide. Already covered. This is the study area. Next, quick, please. This is the topographic view in the left side. It's okay. This is the land use of Barind Tract or study area. Left side is the floodplain and the right side is the dry zone. And this is the land use, land cover of two seasons. One is dry season, left one is dry season, and right one is wet season. And next. This is the map on albedo. Left side is albedo of a dry season. Then the albedo is little bit higher, and the right side is the albedo of wet season. Then the albedo is little bit low. Next.
Next slide, Noor.
This is the thermal behavior. Next. This is the climatic behavior of long term. That is first orange one is for 23 years and the blue one is 10 years. There is a little bit changing tone here. Next. This is the surface topography that is delineated from NOAA AVS data for 3 seasons. One is for February, and that is the mid of dry and wet season, and April there is a dry season, and October that's for the wet season. So roughness length is higher in October and lower in dry season. Next, please. This is the drainage pattern That is the geomechanical processes already delineated using the landscape TMA images and shown it here. Next. A 3D view of 3D topographic view here shown here, enlarging the Z direction 250 times, just for shown the pattern of Barind tract. Next. Here it is shown the groundwater sensitivity with the amount of rainfall, and we got a positive result here. The subsurface water reservoir is very much sensitive to the amount of rainfall, that is with the sensitivity of surface water availabilities. Next, please.
1 minute, Saji.
Ji, please. It's okay. Please. This is the groundwater, this is the subsurface condition. Next. Okay, is finding result of conclusion, however it is. The main tools, geospatial technologies, especially remote sensing, GIS, including geophysical technology, provides the effective means of monitoring such as geomechanical processes like that prevails in Barind tract, especially in Barind tract, elevation and the surface topography, along with relatively high rate precipitation, is to be one of the driving force of dryness of Barind tract. That's all. Thank you for hearing me.
Thank you so much for giving that presentation very quickly. Much appreciated. Our next speaker,
thank you.
As we move into the agricultural adaptation against water stress, our first speaker is Dr. Ilyas Hossain from the Bangladesh Wheat and Maize Research Institute. He's talking about climate smart conservation technologies. It's a promising tool for saving natural resources with sustainable crops and soil productivity in drought-prone barren tract. Thank you, Dr. Ilyas. Please go ahead.
Thank you so much. Welcome everybody to my presentation. Grateful honorable chair and co-chair, distinguished scientist and distinguished expert member from home and abroad, and ladies and gentlemen, good afternoon, everybody. So I am welcome to my presentation on 7th Gobeshona International Conference 2021. So my I'm Ilyas Hossain, Principal Scientific Officer and Head Regional Station, Bangladesh Wheat and Maize Institute, Rajshahi. The aim of the study, saving natural resources with sustainable food security, and objective of my study, increase sustainable crop productivity in Barind region, resource saving, that means time, water, labor, energy, money, soil, etc. Environmental friendly and easy crop cultivation to avoid pest and diseases and minimize greenhouse gas emission. So my title of my experiment, conservation agriculture is a promising tool for saving natural resources with sustainable productivity in drought-prone Barind tract. And already discussed by him and objective of my presentation. The materials. So we have three factorial design. First factor is, conservation agriculture, that means in less tillage or minimum tillage, and that is second is residual retention, and third is also crop diversification, that means wheat, maize, rice cropping pattern, and this is nitrogen level also, and design is steep plot design and application free. And the some background in global climate change in Barind tract, major concern for drought prone area, prone agriculture in Barind tract also, and also temperature rising, sometimes fluctuation in every year, and also erratic rainfall in crop season, and organic matter degradation, and also groundwater depletion. This is a common scenario in Barind tract, also in drought prone area also. And solution by conservation agriculture, that means 3 pillars of the conservation agriculture. I also mentioned the no or less tillage, biodiversity crop rotation, and also cover crop of the soil. This is the, and but how? Conservation agriculture is an opportunity to save natural resources, that means water, labor, time, fuel, energy, and carbon dioxide, cost of production also, increase organic matter, also less carbon dioxide, also labor showing. This is now burning issue in our country now, labor. So this is also the result also from the some it also mentions some results labor saving and also it is soil some physical properties after 16 years. This experiment also is 16 year crop cycle, that means 48 crops in that. So we can some result finding in soil physical properties in the bulk densities some reduce and water infiltration rate and total process is increasing in every year, and color of the soil is blackish color in conservation agriculture system. So finding and result of our research, save irrigation water about 25 to 35%, and save 26 to 40% labor and 44% fuel and 40% carbon dioxide. Reduce rat damage about 80%. It is the major problem in wheat in our country, especially Barind tag. System increase about 12 to 15%. Increase nitrogen use efficiency about 19 to 31%. Increase soil organic matter 0.82% after 16 years. Reduce bulk density about 8.3%. Increase infiltration rate about 47%, and total forest space 38.5%, gives higher income. Economic return near about 1.8 times. So conclusion and message: considering to saving labor, water, fuel, and net damage, time, money, soil, and carbon dioxide, we could conclude that conservation agriculture appears to be a very promising technology for sustainable intensification in rice system in drought-prone Barind tag. So thank you all. This is my thank you for patient hearing my presentation. Thank you all.
Thank you, Dr. Elias. It's great to see a long-term trial. They're very, very important to demonstrate this benefit of conservation agriculture. Thank you.
Thank you, sir. Thank you for hearing me.
The next speaker is Dr. Arif Islam from the Bangladesh Agricultural Research Institute. He's talking about agronomic performance of lentil under conservation agriculture in a rice-based system in northwest Bangladesh. Thank you, Arif. Please go ahead.
Okay, thank you. Can I share my screen?
Yeah.
Yes, go ahead. Go ahead.
Okay. Okay, thank you. Honorable Chairman, moderator, distinguished guest, and scientists from different organizations, good afternoon. Now I'd like to present one of my paper, that is agronomic performance of lentil under conservation agriculture in rice-based systems of northwest Bangladesh. Before going forward, I would like to give you some brief of my presentations. That is, intensive rice-based cropping systems have played a pivotal role in increasing food security of that regions. However, the degradation of soil and water resources, increasing production cost, water, energy, and labor scarcity, and diminishing farm profits and uncertain weather events poses a threat to the sustainability of the systems. So we hypothesized that the conservation agriculture is a climate smart technology, can improve the crop performance and sustain the crop productivity. And so you work out the research question: what are the changes of soil disturbance and residue retention on the agronomic performance of lentil under conservation agriculture in a rice-based systems of northwest Bangladesh. Now, next, please. There are three types of soil disturbance, that is strip planting system, no tillage, and conventional tillage assigned in the main plots. And two levels of residue retention, that is high residue and low residue retention, assigned in the subplots, replicated 4 times in a split plot design. The crop rotation we used that lentil, mung bean, and monsoon rice. But for clearing and concise presentation, now I would like to present only lentil crop. And this experiment conducted in the northern part of the Bangladesh. Next, please. Next. Now the results. Clearly, as you see in this left side bar graph, that soil water content and root weight densities has a significant effect due to tillage and residue retention. And steep planting system and high residue retentions increase the soil water content. However, at the right side bar graph, you see that the incidence of diseases, that is stem phylum diseases and aphid infestation, so also reduced about 30 to 40% by conservation tillers as compared to conventional tiller systems. And as a consequence, the yield increased with conservation agriculture systems, about 24% for crop number 7 of lentil crops. That is under conservation agriculture systems, that is steep planting systems and high residue retention plot as compared to conventional tiller systems. Next, please. Finally, in a nutshell, I can say that application of conservation agriculture practices, that is steep planting systems and high residue retentions, improve the soil water content and root growth and reduce the diseases, that is aphid, stem phylum blight and insects, that is aphid infestation. And it's also reduced the weed incidence and weed seedbed size for the dryland crops. And finally, that increased the lentil yield. That is all about my presentation, and thank you for patient hearing.
Thank you, Dr. Arif. Very good. Our next speaker is from the On-Farm Research Division at BARI, Shakhawat Hossain, talking about integrated farming, a livelihood improvement technology for resource-poor farm households in drought-prone high barren tract. Thank you. Please go ahead.
Thank you very much for giving me a chance. Can you hear me, sir?
Yes, I can hear you very well. Please continue.
Okay, thank you. Actually, my webcam is not working, so my face is not shown in the computer. So I am presenting my research work. Okay, my research work is integrated farming, a livelihood improvement technology for resource-poor farm households in drought-prone high barren tract of Bangladesh. And we are 5 authors here. I myself, Dr. Mohammad Shakhawat Hossain, Dr. Jagadish Chandra Burman, Dr. Mohammad Mazharul Anwar, Dr. Mohammad Farooq Hossain, and Dr. Akkas Ali. We all are on-farm research scientists of Bangladesh Agricultural Research Institute. Actually, in the high barren tract, prolonged drought, high temperature, uneven distribution of rainfall due to climate change, soil acidity, and low soil fertility are major stresses affecting agricultural production. But I think we are thinking productivity can be increased through proper utilization of all resources of poor farm household under an integrated approach. Our goal is this is the project activities and the project funded by NATP phase 2 of BARC, Bangladesh Agricultural Research Council. Goal of our study is maximizing farm productivity through dissemination of farming system research technologies and efficient use of farm resources. And a specific objective to maximize the farm productivity and efficient utilization of drought and rain-fed ecosystem, to integrate component technologies, that means crops, livestock, fisheries, agroforestry, and homestead gardening, etc., for improving farm practices and establish linkage with the different stakeholders, and to create awareness about modern agricultural technologies among the participating farmers, and finally to improve family income and livelihood through empowering women in farm activities. We have 2 locations of high barren tract. First one is Farming System Research and Development Site, Bosantapur, Rajshahi, under Bangladesh Agricultural Research Institute. And second location is multi-location testing site, Amnura, Chapainamabganj, under BARI. Our target group is marginal, who had the land of 0.2 to 0.022 to 0.2 hectare, and a small 0.2 to 1 hectare land, and medium 0.1 to 3 hectare of land. This category was done by Department of Agricultural Extension 2016. And 4 farmers from each category, and the total number of farmers in each site were 12. So the total number of households for our activities was 24. Now, activities at a glance. We categorize, we divided into 5 categories of activities. First one in homestead production system using Barind model. Actually, on-farm research division of Barind station developed a model in the homestead area activities. 9 space was considered for the homestead area for vegetables and fruit production, and this is the number 1 activities. Number 2, field crop production system using modern technologies. Here 2 activities included: improvement of cropping pattern and validation of crop varieties. Number 3, livestock system activities. We our activities under livestock was deworming and vaccination of the cattle and cattle fattening, rearing of sonali, chicken, pigeon, duck, and fodder production. And under 4 activities, fishery system. Normally farmers have mini pond beside the household by homestead, and in maximum time this pond is go under idle condition, and they not use this pond scientifically. We use this pond. Yes, we use this pond under poriculture in mini pond and scientific way, and we synthesize the farmer in off-farm activities under sewing machine and 2-wheel tractor machine and auto rickshaw. Now I would like to show the results before intervention our activities and after intervention our activities. In Bashantapur site, before intervention in homestead, from the homestead, the gross return was about 5,000 taka, and total variable cost was more than 800 taka. So gross margin was 4,120 taka. But after intervention our activities, this gross return increased into the 24,000, more than 24,000 taka, and total variable cost was also increased 3,175 taka. So gross margin was more than 20,000 taka. Similarly, in field crop activities under, it was 3,34,000 taka. Again, livestock activities, it was about 30,000 taka. And
come to the end, please.
Yes, please.
Out of time.
So gross margin, considering all the sector, about 95% gross margin was increased in the Bashantapur site. Similarly, in Mamunur site, it was more than 100% gross margin increased. So we can say the gross margin and production can be doubled for utilization of integrated farming system. And finally, lesson learned of our activities: an integrated farming is an eco-friendly approach in which waste of one enterprise becomes the input of another, thus making efficient use of resources. In addition, every inch of land can be used in the system. Women employment has been created in their homestead activities like vegetable production, management of fruit trees, poultry rearing, cattle rearing, and composting. The vital indicator for livelihood improvement is increase in income compared to existing condition, which was successfully obtained from this program. So we can say integrated farming is a promising technology for livelihood improvement of resource poor farmer. These are the some pictorial view in our activities. This is mango management and fruiting, vegetable production, chicken production, vaccination, field crop, 2-wheel tractor. This is all about my presentation. Thank you for patient hearing.
Thank you so much. Thank you so much. Our next speaker is from the BMDA, Mamunur Rashid. He's talking about adaptation of crop turnaround time, reducing practices for irrigation saving in the Barind tract. Please go ahead, Mamunur.
Good afternoon, everybody. Welcome to my presentation. My title: Adaptation of crop turnaround time reduction practice for irrigation saving in Barind tract, a case study in Joypurhat district. Next, aim and objectives of my study: to investigate farmers' practice to adapt the climate hazard situation using soil moisture and for potato and minimum or zero tillage for boro rice cultivation as an action of locally led adaptation through reduction of turnaround time and efficient use of soil moisture. Next. Methodology of study. The study was conducted in Khetlal and Kalai Upazila of Joypurhat district. We have collected irrigation related data of 200 farmers from both upazilas for last 2 years. We discussed with 4 FGDs with 50 farmers for both upazilas. I prepared 6 case stories on farmers' livelihoods and adapted practice. Next. Major findings of my study. Farmers usually prepare land 10 to 15 days and then transplant potato seeds. But farmers of the study areas are now transplanting potato seeds within 3 to 4 days after harvesting almond crop in November, using soil moisture that reduced fast irrigation in potato crop. For this, farmers saved about 5 lakh liters of groundwater extraction for 1 hectare of potato field. Then, farmers transplanting boro rice seedlings in February in same land, adopting minimum or zero tillage technique, which saved about 6.5 lakh liters of groundwater per hectare in land preparation for boro rice transplantation by reducing crop turn around time. Overall, the irrigation cost saved by 20% and 17% respectively in potato and boro cultivation. Next. Recommendation and conclusion. The crop turn around time reduction practice in almond, potato and boro cropping pattern has created window for fourth crop like leafy vegetables cultivation, especially in Kharif one season. This practice would increase the system productivity and economic return with minimum use of groundwater in crop cultivation. So the practice could be demonstrated to other areas of northern and western part of Bangladesh. This is all about my presentation. Thank you.
Thank you so much, Mamunur, for a very concise presentation. Much appreciated. Our next speaker and the final speaker in our agricultural adaptation section is Debashis Saka from the Pulse Research Centre at BARI, talking about the challenges and potentiality of pulse crop cultivation to adapt to climate change. Thank you, Debashis. Please go ahead.
Can you hear me?
Yes, I can hear you very well.
Okay, thank you, sir.
No, go,
Hello.
no.
Hello.
Go for,
Hello.
Go for first slide. Last one.
Yeah. First slide.
আপনারটাও ভালো হয়েছে স্যার। আপনার তো so much স্যার মানে a lot of resource ছিল স্যার, ইনফরমেশন ছিল।
Engineer Alamgir, just
okay.
Okay.
Can you hear me, sir?
Sure. Go ahead.
Hello.
Go ahead, Dr. Debashis.
Participants, ladies and gentlemen, welcome all of you to participate in my presentation. Good afternoon, everyone. Actually, it is very difficult to discuss many things within a very short time. My topic is challenges and potentials of pulse crop for adaptation to climate change in the high Barind tract. You know, cropping pattern is quite different in Barind tract to other areas of the country. I am working on pulse crop. We have different pulse varieties which can be adapted in high Barind tract. The main objective, enhancing pulse production for nutritional and food security. The objective of our concern to identify the constraints of pulse production in high barren tract, explore the potentials of pulse crop, introducing existing suitable pulse technologies, which is available in our Pulse Research Center, strengthening research and addressing problems in high barren tract. Next. Actually, we have some problems like abiotic and biotic stresses. Among the abiotic stresses, drought is the major concern in high barren tract. High temperature is also problem in Barind area. Water logging, soil acidity, and micronutrient deficiency is also concern in our pulse production. Among the biotic stresses, stem phylum blight disease is a major problem in lentil and other crops. Root rot, foot and root rot, this is also another problem in different pulse crop. Fusarium wilt, botrytis, grey mold, although this is decreasing in recent years. And yellow mosaic virus is another problem in pulse production. Crop competition, particularly in irrigated rice, crop competition is actually major concern in high barren tract area. Actually, water scarcity, the main characteristics of Barind, uneven topography. This is the main characteristics of high Barind area. So water irrigated water is a major problem. We are lucky enough because less water requirement is very less during pulse cultivation. So we are thinking about the introduction of different pulse varieties in cropping pattern of high barren tract. This is our major concern. Actually, we have already, I have mentioned, the cropping pattern of high barren tract is quite different from other areas of the country. Most of the cases, rice, fellow, rice, fellow, rice. So we can introduce, we have the opportunity to introduce of different pulse varieties in fellow land. So
1 minute, please.
It needs short duration pulse varieties in between two crops. So we can utilize fellow lands in high barren area. So shoreland and saline coastal area, this is another area we can use for pulse cultivation, which can improve our total productivity and requirement of our pulse crop. We are producing 16 lakhs metric tons of pulses using 10 lakhs hectares of land. But our requirement is around 26 lakhs metric tons. So we are in deficit situation. If we can increase our total productivity using fallow land, shoreland, coastal area, so we can improve our livelihood of the concerned farmers. Next. Next. So my last message, we have the technologies, we have some promising varieties that can be introduced in high barren tract, especially lentil, cashery, chickpea, etc. So in short, this is sharing. Thank you.
Thank you, Debashish, very much for that interesting talk about pulse crops and their adaptation to the barren tract. Our next speaker, talking in the social adaptation approach area, is the General Secretary Sarwar Kamal from the Centre of Capacity Building of Voluntary Organisations, CCBVO. He's talking on drought adaptation for ethnic community by Rockagola, a food security model in the barren tract. Thank you, sir. If you could go ahead.
Thank you very much. I am Sarwar Kamal from CCBVU Rajshahi, Center for Capacity Building of Voluntary Organization, working with ethnic community for food security and sustainable development of the ethnic community, with the support of Bread for the World Germany, and our this research is also part of the project. Our research title is Climate Change Effect on Ethnic Community in Barind Tract. Next. Aim and objectives. Our in the Barind Tract, we try to understanding climate change effect and on ethnic community people, people's livelihood in the Barind Tract. Major challenges faced by the ethnic community due to climate change adverse effect. Next. Methodology. Analyzing weather report of the Barind Tract from secondary data in different secondary data, and in the second, interview of different stakeholder with specific questionnaire. Third, focus group discussion, and fourth, sampling survey with a closed-ended questionnaire among the ethnic people. And next, findings. Groundwater level of the Barind Tract is discarding rapidly, which also causing land degradation and water scarcity. Second, average temperature of Barind Tract increased along with starting rainy and winter season. Third, Rockagulla model is likely to improve food security and climate change adaptation skill of the ethnic community. Fourth, climate smart agriculture could play a crucial role to reduce stress on the groundwater level, as well as climate change adaptation capacity of the ethnic community in Barind Tract. Thank you very much.
Thank you so much, sir. Very good for keeping to the time. Much appreciated. However, gentlemen, and ladies as well, we are running very, very short of time. So we may have to we will have to forego a discussion session because we'll finish very shortly our time at the conference. So to that end, I would like to pass directly to Baz for his comments on the session, and he'll be able to give us some feedback and comments. Baz, if you wouldn't mind, go ahead, please.
Thank you, Alan, and thank you, Dr. Akram, for inviting me to join and allow me to listen to all these interesting presentations that describe the challenges of Barind Tract and all the different solutions that everyone is working on, which is very heartening to see. I have not been able to return to Barind for a couple of years, but it's close to my heart, as Dr. Akram and many of you know, and also good to see some good friends here, old friends, Professor Chowdhury, Jahan, and others. So I wanted to just maybe take 1 minute to show you something that it might be of interest to you that I'm currently working on, which is where the science and the practice comes together. And so I will see if I can share my screen and see. Can you see my screen now?
Yes, we can see the screen.
Okay, so this is where the science and the practice come together, where you use satellite information to give farmers, smallholder farmers, precise information on irrigation, soil moisture, etc. So this is Punjab, and we're doing a pilot with a number of potato farmers in the Punjab, so quite similar to Barind. So if I zoom in, what you see now is the vegetation cover of these various farmer fields. And when it's red, I know this is harvested, so we don't have to worry about the harvested areas. But then when it's blue, and there is vegetation cover, and it's still something which is in production. And now we see here, right away in this graph, what's the soil moisture profile. The soil moisture profile goes from the 15th of October to, I mean, on the right side, I don't know if you can see it, the videos, to yesterday. It's daily information on soil moisture. So here the farmer knows exactly when he is over irrigating and when he is under irrigating. So everything above the blue line is actually too much irrigation. So there is, there's excess evapotranspiration, all this percolation back into the groundwater. When he's going to the red zone, he's in water stress. So this is something where you can, one snapshot, you don't need soil sensors anymore. You can really see from satellite information what is going on the average root zone, not a specific place in the field where you put the sensor, but the average root zone. So from there, you can go to all kind of other interesting information. This is the daily accumulation of biomass. This is the accumulated one. So here the farmer knows if he's doing well or not doing well. You see the crop is growing. Actually, this field is doing 1,600 kilo per hectare after, towards the end of the season. It's not a very good farmer. He's probably facing some different issues. So anyway, I don't want to dwell on this because time is running short, but you can do this. So there is a benefit for farmers, but it's also a benefit for authorities because you can aggregate the information from the farmers. You can actually do IWRM that some of you were talking about, with actual information in the field. So just wanted to give the snapshot. If anyone is more interested in more of it, I'm happy to provide further information. But something where state-of-the-art technology, this is used now across about 15, 20 countries. Thousands of farmers are using it. It's been available on the market for about 1.5 years now. And it's mainly taken up so far by larger farmers, California, Mexico, South Africa, commercial farmers. But the work we're doing in India is to bring it to the hands of smallholders. So then, of course, the question is, how do you bring a picture like this on the cell phone of a farmer? So that's where digitalization of the rural landscape becomes important. And there are more and more farmers using smartphones. Some are still using it just for making pictures, but others are actually starting to access information to improve their management on their management practice, farm management practices. This is a tool. I mean, it's coming. I mean, I'm just giving you a snapshot. I'm sure it's coming there in about 5 or 10 years. It's a common practice for farmers to get that information. But I thought to quickly share this with you. I think Barind Track would be a very good place to see if we could, bring this technology to farmers across the various crops that are grown there. And so the three major objectives are, of course, crop productivity, and get the right amount of water in the root zone to maximize crop growth. And the second is water use efficiency. So you don't give too much water to the plant either. So I wanted to quickly share that with you. Dr. Akram, my heart is with Barind, as you know. I'm very happy to see that Barind is got a separate section in the Gobeshona Global Conference. I should congratulate also Professor of Dr. Salimul Haq for putting this together with so much efforts and so much consistency. I think it's a great initiative, and I thank you all for sharing your wisdoms and let us continue supporting the farmers and the communities of Barind Tract with the right sciences and the right knowledge. So with that, thank you so much for giving the opportunity to say a few words. Thank you.
Thank you, Baz. It's much appreciated. And I really agree with what you're saying there. You know, moving to a hybrid measurement approach where we're looking at a mix of direct measurements and modeling and remote sensing, it seems to me to be the most effective pathway to achieve, you know, low-cost accounting systems for soil carbon, water moisture, like you just demonstrated. I think they're great tools for farmers and of course the land managers as well when we're talking about the barren tract to conserve what we do have and regenerate what we did have. So they're important measuring tools, especially getting that big data together and using that as a very informative tool for helping us in the barren tract and other arid areas around Bangladesh and other places. So thanks again, very informative. I would like to move on to the last section now, which is back to Dr. Akram Hossain Chowdhury to give the vote of thanks to end our session today. Thank you, Dr. Chowdhury. Don't think we can hear you. You're muted, sir. Unmute your microphone.
Hello.
Hello, there you are. Well done,
Yeah.
thank you.
Yeah, it is time to express my heartfelt thanks and gratitude, all of you. You know, giving your time and insight, presentation, everything, whatever needed for the successful success of this, success of this kind of webinar Zoom meeting on Barind tract. And we are really grateful that we have done it very timely. Although I'm sorry that we cannot left out some question and answer session. Anyway, we are here. If someone try to contact us via independent university, we'll try to feed you back your answer of your question. Now, the last speaker, I must pay my special regard to Bashir Mohammed, who is a water engineer by profession, but then he has the extensive knowledge of Asia and Middle East for his career in the International Finance Corporation of the World Bank Group, and Bangladesh was his domain. So as a matter of fact, he was the instrumental to organize, establish Barind Integrated Landscape Transformation Multi-Stakeholder Platform, and as well as this meeting organized in cooperation with the ICAD, organized by BMDA, Barind Multipurpose Development Authority, and Rajshahi University. Professor Sarwar Jahan has contributed a lot here in this seminar. So also presented as a keynote speaker, presented a concept note, and especially I thanks to Professor Salimul Haq, who was always very inspirational to Barind program. So I can commit that with this group, we'll sit together immediately after this, and then come back with a plan of action, as Professor Salimul Haq actually need to give him by 22nd of this month. So maybe we can discuss with the group members what should be our plan of action next, and we can give them that so that we can continue and carry out the result of those recommendation of this seminar webinar. And I really finally I want to give thanks to the team member Nouri Elahi, who has done a lot. Shohel supported us a lot on the for the success of 7th Gobeshona International Conference, and dryland and Barind, the adaptation for water stress Barind dryland, northwest Bangladesh. Especially, I thank to Dr. Alan David McHugh, who has actually taken the trouble of coordinating all those things and moderating things. So I must respect to all those things, all those people, scholar who presented the papers and make it a success. Thank you so much. Have a nice time.
Thank you, sir. Assalamu alaikum.
Thank you, sir.
Assalamu alaikum. Assalamu alaikum.
Thank you,
Thank you,
sir.
everybody. Good afternoon.
Thank you,
everyone.
sir.
Thank
Thank you, sir. Thank you very much. Have a nice time. Raj.
Thank you very much, sir, for giving chance. Thank you very
Come to
much.
Bangladesh, Bas. Come to Bangladesh.
I will try. Absolutely. Look forward to it.
Don't forget to take Frederica with us. With you.
Thank you all very much.
Thank you very much.
Have a nice time. Bye.
Bye.
Thank you.
Bye.
Bye-bye.